Hi there, folks. This is the Practice Chapter 6b test, and as always, I am the amazing Mr. Jansen, so away we go. If we look at this first one, it's just asking us really, when it says f plus g of x, it's just asking us to add those two functions together. So I'm going to take my f function, which is the x squared minus 2x plus 2, and I'm going to add my g function, which is the x plus 3. So now I'm just simply combining like terms. That's going to give me an x squared minus x plus 5. And that's it. In the second one, the notation here is just telling me to subtract these two functions. So I take the f function, which once again is this guy, and I subtract the g function. And keep in mind, we're subtracting this entire thing, which means I'm going to change this to adding the opposite and then combine like terms. So this time I get an x squared, a minus 3x, and a minus 1. Okay? So again, it's all about just reading this notation. Number 3 is very similar. In this one, it's telling us to multiply the two functions. So I take the f function, which is the x squared plus x minus 5 this time, and I'm going to multiply it by the g function. And that's all this notation is telling me to do. Now I just have to use my distributive property. That's going to give me an x cubed plus 4x squared. And then I distribute the x. That gives me an x squared plus 4x. And then distribute the negative 5. That's a minus 5x minus 20. And then I combine like terms. That's going to give me an x cubed plus 5x squared minus x minus 20. And that's it. In number 4, it's asking me to divide the two functions. So this time I take the f function divided by the g functions. That's an x squared plus x minus 5 divided by the x plus 4. And there's two ways we can look at dividing this thing. Well, really 3. I could use long division, but that's really out because I can use synthetic division. So synthetic division would be a good option here. Or see if this thing can factor and cancel out any common factors. I might try building a bridge. I get a negative 5, two numbers that multiply to a negative 5 but add to a 1. It's just not going to happen. Okay, so there are no two such numbers, which means I can't factor that thing. So I'm going to have to go to synthetic division instead. So I take this guy, the thing I'm dividing by, the opposite of that, and put it in my box. So I put the negative 4. Then I write down my coefficients. And I would just start my division process. I bring down the 1. I multiply what's in the box times what's underneath. I write it underneath the next coefficient, and now I add straight down. And then I multiply the negative 4 times the negative 3 is a positive 12. I add straight down, that's a 7. And now since I started with an x squared, this interprets as an x minus 3 with a remainder of 7. So I put the 7 over the thing I was dividing by. And there it is. There's my division. So it's nothing new that we're doing here. The only thing that's different is the notation. You have to be able to read this function notation. In this one, an open circle like this means I have, I'm talking about f of g of x. In other words, f of g, this time of 3. And really, this is just substitution. That's what the composition is. It's substitution. I start on the inside, and it looks like I've got a 3 that I'm plugging into the g function. So if I do g of 3, it means I plug a 3 into the g function, which is going to give me a 9. So that means that g of 3 was a 9. So if I plug a 9 in its place, now I'm looking for f of 9, which means I have x plus 1. I plug a 9 into the f function, and that gives me a 10. And that's it. In number 6, I do the same thing. This is g of f of negative 2. So this time, starting inside the parentheses, I've got an f of negative 2. So I'm plugging in negative 2 into the f function. That's a negative 2 plus 1, which is a negative 1. So now I have g of negative 1. I plug the negative 1 into the g function. And I find out that I have a positive 1 here. And that's it. In number 7, I'm doing f of g of x this time. So essentially it's the same thing. I'm still doing f of g, but instead of having a number, I have an x. And really, I do the same thing. If I plug an x into the g function, it gives me this. In other words, if I plug an x into the g function, I get a 3x plus 1. And now if I look at what I have f of this thing. That means I'm going to plug that 3x plus 1 into the f function. So instead of having x squared minus 2, I have this whole thing, the 3x plus 1 squared minus 2. And now in order to simplify this thing, this is a 3x plus 1 times a 3x plus 1. So I've got a FOIL or distribute here. That's a 9x squared plus 3x plus 1. This minus 2 just keeps tagging along for the ride, and then I combine like terms, the 9x squared, the plus 6x, and a minus 1. And that's it. In number 8, we're asked to find the inverse of f of x and then the inverse of g of x. Again, that's what this notation means. This means the inverse. This means the inverse for each of these. So the inverse, we simply switch the x and the y values. So for this one, the f of x had the ordered pair 2, 1. I'm going to change it to a 1, 2. It had the ordered pair negative 3, 0. I change it to a 0, negative 3. The 4, 2 becomes a 2, 4. And the negative 6, 1 becomes a 1, negative 6. And that's it. Okay, that's all I have to do in order to find the inverse. So the inverse of this function, when I switch the x and the y's, is this guy. If I look at the inverse of g of x, I'm doing the same thing. So the inverse function of g of x, I just switch all the x and the y values here. I had a 4, 2. I change it to a 2, 4. I had a 0, 5. I change it to a 5, 0. I had a negative 2, 3. I change it to a 3, negative 2. And now we're asked a couple questions about the function and the inverse we just found. So in number 8, as I continue down here, they're asking, is this function 1-to-1? And for a function to be 1-to-1, essentially the f of x would have to be a function, and the inverse of that would have to be a function. And when we look, we don't have any repeated x values here, which means my f of x is a function, but the inverse has a repeated x value of 1, which means the inverse is not a function, which means this is not 1-to-1. So the answer is no. And the reason is because the inverse is not a function. When we talk about 1-to-1, it's essentially a step up from a function. A relation is a set of ordered pairs. Then a function, every x value has exactly one y value. And then 1-to-1 is a function, so every x has only one y, but every y also has only one x. Okay? In the next one, number 9, the g of x, the inverse that we found here, we're just seeing if that's a function and the original is a function. So when I look at this, I have no repeated x values, which means this g of x is a function. And then if I look at the inverse of g of x, I still have no repeated x values, which means every x value has one y value, every y value has one x value, which means this one is 1-to-1, okay? Because both the g of x and its inverse are functions. Okay, so that's just a quick test to see if something is 1-to-1, all right? In number 10, we're asked to find the inverse of g of x. So again, think of g of x in terms of x and y. This is y equals a 3x minus 6. And if I want to find the inverse, I simply switch the x and the y. Before I had values that I switched in the ordered pairs. Here I have an actual x and a y, so I switch them, so I write it as x equals 3y minus 6. And now I just solve for y. We always write equations in terms of y, so I have to add the 6 to each side. That's going to give me an x plus 6 equals a 3y. I divide each side by the 3. So I find out that y equals a 1/3 x plus 2. And then if I want to write this back in my function notation, it's going to look like this. And that's it. I'm going to do the same thing with the next one. Again, I think of this in terms of x and y because I'm just going to switch the x and the y. So that's y equals x squared minus 2. So I switch the x and the y. I rewrite this as x equals y squared minus 2. And now I'm going to write it in terms of y. I add the 2 to each side. So I find out that x plus 2 equals y squared. I take the square root of each side. And this is where I have to be very careful. So I'm left with y equals, since I took the square root of each side, it's going to be plus or minus the square root of x plus 2. And that plus or minus is very important. So back in function notation now, got my plus or minus square root of x plus 2. And that's it.